Good Lord, ride all the way.
A 10,
9,
8,
7,
6,
5,
4,
3,
2,
1.
Hello and welcome to Slooh, especially Slooh members joining us on the 24-hour channel at slooh.com. Don't forget, you can snap images using the StarShare camera below the video panel, and you can also use the chat box to the right if you want to ask us any questions tonight. Now, tonight, we are teaming up with our friends at Astronomy Magazine to watch Saturn live as it reaches opposition. We'll be talking to Slooh astronomer and Astronomy Magazine columnist Bob Berman a little bit later, and he's going to tell us everything there is to know about the most beautiful, I think, of all of the planets, that ringed gas giant Saturn. Now, everyone remembers their first glimpse of this gorgeous, gorgeous planet through a telescope eyepiece. So tell us using at Slooh if you have that one of those memories of your first glimpse of Saturn. And later in the show, we'll take a look at some of the ancient cultures who saw Saturn as an important figure in their belief systems and how that figure gave us one of our favorite days of the week, Saturday. Woohoo! We've got live views of Saturn directly from Slooh's flagship observatory at the Institute of Astrophysics in the Canary Islands. Here it is. It's just off the west coast of Africa. We are alongside some of the largest telescopes in the world up there. We're at an altitude of 8,000 feet on top of this volcano known as Teide on the island of Tenerife. That's just off, as I say, at the west coast of Africa. Now, prevailing winds come in from the Atlantic Ocean, which means the air is incredibly stable when it hits the islands. And this produces the superb seeing conditions experienced at the observatory, especially at the altitude of the observatory as well. Not many people know this, but the largest optical telescope in the world is based in the Canary Islands, the massive 10.4 meter Grand Tecan. Now, that is our all-sky camera. I'm just checking actually to make sure that's an up-to-date image, if we can do that. That's the special camera, the low-light camera that members use who are controlling the telescopes to check the sky conditions. And that's an old image, I think. So studio, if you can get that one updated, because I don't think the moon's up at the moment, actually. Anyway, I'm going to be joined by Slooh astronomer and Astronomy Magazine columnist Bob Berman later, and we'll point out where Saturn is and how you can spot it from your own backyard tonight. We also have our new constellation cam, and that's providing a beautiful, beautiful ultra wide field of view. It's some 24 by 16 degrees across, and it's terrific at showing us the context of our primary target, Saturn. And Saturn actually is the brightest dot to the left of that image. The really bright one to the right, that's actually Mars still, and Bob will tell us all about the constellation Scorpius that it's in as well. Now, we also have our little wide field telescope, and although Saturn may burn out a bit, we've set that one up so it takes a longer exposure. And if you, Slooh members, snap that in the StarShare camera, zoom in, and you will be able to see probably 4 of Saturn's largest moons. Now, some of them are actually within the glare, so you have to be a bit careful how you try and identify those, but that's a really nice view if you want to spot Saturn's moons. We also have our 17-inch telescope tonight. That's going to come online a little bit later, and we're processing those images, and there is the first image coming in. So it's black and white to start it off with. It's grayscale to start off, and then it goes into color. That's using Slooh's patented systems and methods to do that real-time processing from a 17-inch telescope with a CCD camera. It's really difficult actually to image something so bright as a planet in a telescope that big. That's a nice problem to have, isn't it? Any astronomers out there? Anyway, we also have our live Celestron video solar system telescope, and this is giving us a great view of Saturn. You can see it's wobbling around there. That's the seeing. It's still The observatory has been open now for about 4 hours, so really the air is still settling down. The equipment as well is still hot, so that's still radiating a bit of heat. But we're getting some lovely, lovely glimpses of that through that telescope. Now then, we also would love to see your images of Saturn. If you've imaged it over the last week from your own observatory or anything like that, then please tweet us the image to @Slooh. And if you own your own telescope and would like to join our network of observatory and event partners, just drop me a line, paul@slooh.com. Now then, you can also ask, if, by the way, astronomy magazine readers out there, you can also ask us questions to @Slooh as well. Now, let's welcome Bob Berman onto the show. Bob, thank you so much for joining us tonight.
Are you kidding? This is such a pleasure on the night of the opposition of Saturn. And I'm looking at this, and, sure, all of us who have good sized backyard telescopes or observatories know that in those rare moments of steady seeing, we see amazing detail. I don't care. This is. This is still a knockout, and we're doing the same thing that observers from Galileo on have had to do, and that is wait for those moments when the seeing
Yeah.
steadies, and then we see all the detail that there is to be seen, including that beautiful black division between the rings that comes and goes
Yes.
in the air tonight. This is so much fun tonight.
It does, and we had better conditions the other night, and we posted some of the video captures in the Slooh Clubhouse for members, and they've been using the process that used to be called webcam imaging, but it's properly called lucky imaging. And wow, Bob, I mean, look, this is one of the images. This is from member David Malak, and what a glorious image that is. And that's from this same telescope using lucky imaging techniques. We may talk a bit about that a bit later on. And we got two of the moons there as well, of course, which was a great added bonus. And Bob, we were talking about this the other night, actually, that we're going to talk about the changes of Saturn, over the years. But one of the things I love when Saturn's facing us like this is you get to see the planet through the Cassini division. You can just see it there. It just adds this three-dimensionality, I always think, to it.
Yes, all three rings, if you're new to Saturn, the outermost thinner, darker A ring, the widest, brightest ring, the B ring, obviously people without any imagination were on the IAU's naming committee here. And then the C ring, which is very intriguing because that's semi-transparent, and that's the ring that you only see where it passes in front of Saturn, the that skimpiest ring. But to me, the exciting thing is that because of the long orbit of Saturn, after all, that's why we have the word Saturnine, meaning someone who's heavy and sluggish and sad, because it takes so darn long to go around the sun, 29.4566 years. I remember that because that's the code on my attaché case, 29.4566. So in half that period, about 15 years, it alternates showing its south side and its north side. But when we're seeing this, the north side close up, and technically it's next year when it's the widest open, but we're within 1 degree of that now. And if we, yes, look at this image. Notice how the outermost part of that A ring, the outermost bit of ring, goes completely around the planet's ball. And the ball itself squashed because Saturn is the most oblate of all the planets. Huge, 78,000 miles in diameter. This is huge, almost 10 times the size of Earth. And look at how that outermost ring manages to fit behind and above the planet. It's not blocked at any point. And you only see that for about 3 years during the maximum tilt of the rings. Maximum tilt is just under 27 degrees. It's 26.7 degrees. We're at about 26 degrees now. And so look how that Cassini division just about skims the top of the planet. And those are our earmarks, our milestones for ascertaining how wide open those rings are. And because the rings are twice as shiny as the planet itself, that's what's bringing Saturn to a magnitude of 0.0, same as Vega tonight. It's
Bob, did you say
last
week that the Cassini division never becomes fully visible behind the planet itself? even at maximum tilt, or will we
Yes,
see the
and
Cassini division
we
behind it next year?
that's right. And you're seeing it's just barely being blocked, but the
Mm,
outermost part of the A ring is not blocked. And that just shows that's we're just about there to that maximum 26.7 degree tilt. And boy, how yummy that is. And in this image, taken through the Great Slooh telescope, you can see the bands of Saturn. Yes, you don't have that detail, the festoons, the curlicues, the white spots and the red storm and all the rest that you have on
mm,
Jupiter. Doesn't matter. If you ask anybody what is the most beautiful of all the planets,
yeah.
this is the one that people ooh and ah about. I've noticed in about
Absolutely. I always say, Bob, for myself, I think Saturn's the most beautiful, Jupiter's the most interesting.
yes,
Now, what we were seeing there as well was there was a little bit of shadow that we saw actually being cast on the rings behind the planet. And we're seeing that almost, well, we are tonight actually seeing it directly behind the planet because we haven't actually explained what an opposition is, Bob. Now, some of our viewers may not fully understand what Saturn being at opposition is all about. So, can you just bring us up to date on that one?
well, very simply, as Earth goes around the sun once a year, Saturn, as I just said, takes roughly 29.5 years. So as we line up, that is, Earth is in between the sun and Saturn, we get to our closest point to Saturn. And therefore, it's largest, it's brightest, it's out all night, it rises at sunset, it sets at sunrise, it's at its highest in the middle of the night at 1 a.m. And so we call it opposition. It's also the night happens to be the night of the closest approach of Saturn. Each year, it occurs 378 days later than the year before. In other words, it's 1 year and 2 weeks later. So easy to keep track of. Therefore, if it's at its closest tonight, June 3rd, it'll be at its closest next year at this same time, but 2 weeks later, middle of June, and the year after that, the end of June. So
Yeah.
Saturn's easy to keep track of. Look at this
So
interesting
yeah, exactly. I
image.
mean, here we can see these diagrams that show the geometry of this so clearly. We've got, s- if we're looking at Saturn, the sun is directly behind us, and we're looking directly out at Saturn, all in a straight line. Of course, Mercury is very close to that line as well because it was only at opposition a couple of weeks ago when we did that other show, Bob.
Yeah,
So
yes,
very
Mars
clearly,
bent. Yes.
yeah. So the geometry is says it all there, and of course Mercury now
You
disappearing,
mean Mars.
getting
Yeah,
lower,
I know you're
being
saying Mercury, but I know you mean Mars.
actually yes. Did I say yeah? I meant Mars. Sorry. Yes.
Yes.
I was trying
And
to
I
look
think
at the
everybody
diagram.
knew what you
Yes.
meant, and I almost didn't even correct you because of course it is Mars that's almost in the same line as well, which is kind of unusual that we have these planets, both of these fascinating planets, coming to opposition the same week, coming to their closest approach the same week.
Yeah. So, Bob, that is opposition, and you say that this is obviously the best time to observe it, not only because it's up all night, it rises as the sun is setting, but also because it's closest to Earth. How much difference does that make in Saturn's size throughout a viewing season for Saturn? How much
It makes a
smaller
little
would it
bit.
look than this?
Saturn is 18 arc seconds across. Remember, an arc second is the apparent size of a quarter-dollar coin if it's 4 miles away. So that's a little tiny angle. It's 1/60th of a minute, which is in turn 1/60th of a degree. Very, very tiny. You know what's interesting? Both Saturn and Mars have disks tonight that are 18 arc seconds. So that
Yes.
presents us with a puzzle. Anybody looking south at let's say 10 o'clock, 11 o'clock, especially southeast, they'll see the brilliant planet Mars looking orange. To its left, there's Saturn, magnitude 0. So it's bright too. It's just not as dazzling as Mars. But here's the question for all of us. I'm going to throw this to you, Paul, and
Mhm.
let's give everybody a chance to answer it. If Saturn is so much larger and it's so much shinier. Mars, I almost started saying Mercury too. Mars only reflects about 20% of the light that hits it. Saturn reflects 50%. And the rings are even shinier. They even have a higher albedo. So if they're both the same size in disk, they're both 18 arc seconds, Plus, Saturn has, in addition, the rings that make it even more area, and they're even shinier. Why is Mars 6 times brighter than Saturn tonight?
Well, it's closer to us. Yes.
Right. There, it's closer to us and it's closer to the sun. So it's receiving
Now
much
let's
brighter sunlight.
yeah.
It's actually
So let's have
about
a look at the
18
constellation count.
times closer to us than Saturn is. So
Yeah.
there it is. You
This
gave
shows it
the
so
reason.
nicely, doesn't it? Mars is the incredibly bright orange, ball on the right, and to the left we've got Saturn there. Still in the constellation of Scorpius, but they are moving apart, Bob, aren't they? Mars and Saturn at the moment.
Yeah, they're both in retrograde motion, but Saturn there on the right side is, because it's so close to us, it's speedily moving. Look to its left, you'll see the vertical string of three brightish stars, Beta, Delta, and Pi
Mm.
Scorpii, the stinger stars of Scorpius. And Mars is now to the right of it and still moving right. Saturn's, and then on the lower left is the great Antares, of course, matching Mars and even being its namesake. Ares
Yeah.
was the Greek name for the planet Mars. Romans called it Mars, Greeks call it Ares, and there is Antares. In other words, the rival, the opposite. They're the same color. And then there's Saturn on the upper left side. So we've got a nice triangle going on in the
It
southeastern
is.
sky at 10 or 11
We'll,
o'clock.
we'll, we'll we'll talk actually a little bit later, Bob, in where viewers need to look to see this lovely spectacle. But I want to go back to Saturn for a minute, because unlike many of the planets, Saturn can change really quite dramatically, can't it, from one year to the next?
Yes, that's thanks to that tilt of the rings. Again, the axial tilt is 26.7 degrees, not too dissimilar from Earth's 23.5 degrees. So 15 years ago, actually 13 and a half years ago, Saturn was edge on and the rings disappeared because they're so thin, they're only about 30 feet thick, and yet they're 90,000 miles from side to side. You know, Paul,
Wow.
I always mindlessly, like a fool, repeated something I had read, I think, when I was a teenager, which is that the rings are analogous to a sheet of paper the size of a city block. That is, their thickness is so thin compared to their size, their length, that look at this edge-on view, by the way, while
Yeah.
we're talking, that they're
Yeah.
analogous to a sheet of paper the size of a city block. Well, this morning, for the first time, I wasn't lazy, and I really calculated if that's true. And it's even
Yeah.
more dramatic than that. They're actually analogous to a sheet of paper the size of 10 city blocks wide, but only one sheet
Wow.
of paper thick. So they are really
Amazing.
darn thin. And in fact, seen edgewise, really on the days that they're edgewise, they usually disappear from sight, even through the largest telescopes.
Do they
So that
really? Now,
was
I didn't know that. Now, this is a series of images from Maynard, one of the Slooh members. In fact, one of the first Slooh members, Maynard Pittendray, joined us in 2003, I think it was, and he has collected these fabulous images every year and is showing this amazing dynamicness of Saturn, and at the beginning, when it reappears in the dawn skies, it's always lovely to get your first glimpse to compare it to the last time you saw it at dusk. I mean, these images really show this effect beautifully.
Yes, and now we finally arrived this year and next, and the year after, actually,
Mm.
at the 3 years when the rings are most widely open to view, and therefore the Cassini division separating the A from the B ring is most obvious, and the planet is brightest, and it's a milestone
It
in its
is.
orbit. And here's the live view, isn't it? Live in more sense than one, because this is a video feed, I
Yeah,
believe, isn't it? And we're seeing
that's
it
right.
like live, moment to moment.
Yeah, we need to tune that up a little bit as well, that view. But we've got these fabulous views coming in from all the telescopes. Now, we're going to talk a little bit later, Bob, about how viewers can spot that lovely trio of Saturn, Mars, and Antares a little bit later on. So we'll see you very shortly.
Okay.
Now, Bob, as I say, will be back. He's going to talk a lot more about the planet Saturn and discuss some of its mysterious and fascinating moons and some of the things to watch for when you're observing Saturn yourself. Now, we're going to take a really short commercial break, but coming up next, we've got Slooh's mythology expert, Trisha Ennis. She's going to be telling us about the importance of Saturn in ancient cultures and how it shares its name with some people's favorite day of the week, Saturday. But first, to the new viewers tonight joining us from Astronomy Magazine, if you're enjoying what you're seeing and hearing, I really want to encourage you to become a member of the Slooh community. It's free to try and there's absolutely no obligation. At its core, members control our robotic telescopes, both here in the Canary Islands and our Chile Observatory, via a simple but powerful interface to see all that glows in space. In fact, Slooh members have taken well over 4 million photos of over 50,000 different objects in the sky. Now, I checked the other day, and we're a whisker off delivering 100,000 FITS files to Slooh members so far in 2016. So some of the Astronomy Magazine members might be interested in that. Slooh works just like a jukebox. So one member controls a telescope while the other members get to see what the telescope is viewing live, while then everyone can contribute to the ongoing conversation. We always say we're like cavemen and women gathered around a campfire. We wonder together about the universe and share our great diversity of perspectives. It really is space for everyone here. So please do give it a try. And in the process, you'll be supporting our ability to make programs like this available to the public. Now, don't go anywhere. We are going to be right back with tales of one-eyed monsters, titans, and the goddess of Earth, Gaia, after this short commercial break.
Welcome back to our Saturn at Opposition broadcast here on Slooh. My name is Trisha Ennis. I'm the resident mythology and culture bowl expert here. And today we are talking about Saturn, so it seems like a really great time to talk all about the mythological figure of Saturn and his importance in both ancient and sort of modern cultures. Now, Saturn is a big planet. You probably already knew that, but it is. Now, Saturn, the mythological figure, was also pretty big. Not physically so much, necessarily, but in importance and in power. In the Greek tradition, Saturn was associated with Kronos, who was the father of all of the Olympian gods, Zeus, Demeter, Poseidon, Hades, and so on. But even gods have stories from before they had kids. In fact, Kronos' story goes all the way back to his own father, Uranus. Kronos was the youngest of the Titans, a race of gods who were the children of Uranus, god of the sky, and Gaia, goddess of the earth. Uranus was not a nice guy. Honestly, I don't think any of them were very nice, but Uranus was especially terrible. Kronos hated his father, who was likewise hated by Gaia. Gaia hated Uranus because he cast some of her children, the 100-handed ones, and the one-eyed Cyclopses, into Tartarus, the deepest depths of the underworld. Gaia built a giant stone sickle and gathered together her sons, Kronos and his brothers, to determine which of them would use it on their father. Now, Kronos was the only one willing to do the deed, so he laid in wait, and when his father and mother met up later, he jumped out and castrated Uranus using the sickle. Kronos would later meet a similar fate. After he and his wife, Rhea, began having children, Kronos became paranoid that one of his own kids would kill him, just as he had killed his father. As they were born, he swallowed each of his children whole, and when Zeus, their youngest, was born, Rhea tricked him into thinking a rock was their infant son and hid away the baby god. When he grew up, Zeus returned and cut his brothers and sisters out of Kronos' stomach. Zeus then cast his father and the rest of the Titans into Tartarus and took over as ruler of the skies. Now, when the Romans conquered Greece sometime later, they assimilated the gods and goddesses into their own belief system, including Kronos, who they associated with Saturn, associated with this planet. His role in the Roman pantheon was pretty much the same as it was in the Greek. He was the father of the main gods and goddesses, but he was also worshipped on his own. He was worshipped during the annual festival of Saturnalia, which runs from December 17th to the 23rd. During the festival, the normal social rules of Rome were suspended, and people could do things normally frowned upon, like gamble. Saturn was also the namesake of everyone's favorite day of the week, Saturday. The day was originally named Saturni Dies by the Romans, which translates to Saturn's Day. I think I'll just refer to it as tomorrow. Paul, back to you.
That was Trisha Ennis, Slooh's resident mythology expert. I don't know about any of our male viewers out there, but that one brought a few tears to my eyes. Welcome back. You are watching Saturn and Opposition live at Slooh, in association with our good friends at Astronomy Magazine. Don't forget, you can ask us questions in the Slooh chat room, on the live channel page, or you can tweet us to @Slooh. We want to hear your thoughts and see your images of Saturn, so please send them in and we can share those in the clubhouse. Now, let's welcome back Slooh astronomer and Astronomy Magazine columnist, everyone's favorite, Bob Berman. Hey, Bob.
Well, great to be back. That was fun. It's always fun listening to Trisha, and that even with this pretty horrendous castration and eating the kids and then plucking them out of the bodies, and then since you killed your own father, you're worried that your kids are going to kill you. And all right, so no wonder it's associated with kind of not good things. You know, we have the word Saturnine, meaning depressed and lethargic and heavy, and that comes from yet another aspect of it, which is that it was the slowest, most sluggish of the planets moving against the background stars. So of course they assumed it must have something to do with heaviness, but that's not the feeling we get when we look at it, is it?
And of course, Bob, you know, it's very easy for us to think, well, it doesn't really move that slowly in comparison to Uranus and Neptune. But of course, this was the most distant planet that the ancients knew about, wasn't it?
Yes, and surprisingly so, because since the telescope was first used on the sky in 1610, it's strange that it wasn't until 1781 that any planet other than those 5 ancient ones was ever found. That's when William Herschel, on March 13th of that year, found Uranus. A little odd that no one saw it sooner, especially since any of us can see it these days with halfway decent eyesight if we get away from the lights of a city. It's only about the same brightness as the Hercules globular cluster, which most of us, you know, can see readily when we're out in the countryside away from city lights.
Well, I'm only a few miles away from Bath, and of course that's where Herschel's house was, and he discovered the planet from his own backyard. It's the house now actually is the Herschel Museum. So if anybody is ever visiting in southwest of England, it is worth a visit just for that. You'll see the very part of his basement where he used to grind his own metal mirrors and stuff like that. It's a fascinating place, and they've got a lovely reproduction of his actual telescope there as well. So well worth a visit. Now, Bob, we said at the first part of the show we were going to tell viewers how they can see this lovely spectacle of the brilliant orange Mars. We've got Saturn there, and we've got the bright star Antares. Where should they be looking if they want to see these rise at the moment?
Oh, very simply to the southeast. Best time would be 10 or 11 o'clock when it's coming up in the southeast, and there they are. And this depiction showing that blue line, almost horizontal blue line, is the path of the ecliptic, the exact track of the Earth-Sun plane extended into space. Only one planet actually goes around the sun within 1 degree of that track, and that's Uranus, which is only 3/4 of a degree from it. Saturn's 2.5 degrees from it, so that's why you can see it's above that line. It's rarely on that line, crosses it twice in the course of its 29.5-year orbit. But look at Antares, beautiful, and then to its right, the three vertical stars, Beta, Delta, and Pi, Scorpii, and then to the left, unseen, we begin the great tail of Scorpius with capital Zeta, capital Lambda, Lambda or Shala forming the end of the stinger of the Scorpion. Gorgeous constellation. We've talked about it, you and I, Paul, about how some say Orion, some say Scorpius is the most beautiful of the 88 constellations. But boy, it's right up there. And
when I made this sky chart, I put the overlay of the the antique picture of the Scorpion on it. But really, when you see the entire constellation in the sky, you really don't need very much imagination, do you? That swish of its tail is really the thing that gives the whole constellation away.
It's so true. Many of the constellations, sure, you can see something. For example, as we all know, Sagittarius really looks more like a teapot, a very good teapot, rather than an archer. How many constellations of the 88 really look like what they're supposed to? Orion looks like well, if not a hunter, at least a person. It could be any person. It could be a vegetarian, a serial killer, a burglar, any human figure. But a human figure. And there's not many of them that do that. But Scorpius, arguably, that's the one that looks most like a scorpion. Once you see it, what else could it be? It really looks like a scorpion.
But to have the bonus of that beautiful constellation and have Mars and Saturn in there as well. It's just, the three, Mars, Saturn, and Antares, the colors just make such a beautiful sight. So please do get out there with your own eyes to see the marvelous view. This is a constellation cam. This is a 30-second exposure. It shows us all the color of that, but it doesn't give you really the full majesty of that trio rising in the east in the evening. So Bob, let's go back to Saturn and what there is to see in it visually when you observe it through a telescope. We were saying actually just before the show that a lot of people tend to use too high a magnification and get disappointed with the result through the eyepiece. So what should people do if they've got a small telescope themselves to look at Saturn?
Well, the air will call the shots on any given night. Every visual observer of planets from Galileo onward has seen that there are nights, usually the more humid nights are the better ones, where the air is steadier and where the seeing is good. Kind of amazing that astronomers around the world still use that term, seeing. You'd think that they would have come up with some technical term for it rather than saying, how's the seeing tonight? Oh, it's not very good tonight. Or give it a rating from 0 to 5, sometimes 0 to 10. But you could see the wiggliness in the atmosphere, which is always present. Some nights it's virtually absent, and then you see startling detail. Other times, more commonly, the detail will pop in just for a second or two, and then it'll go back to wiggling to some degree. On nights of very bad seeing, you can't even tell if Saturn has rings. Even through the best possible telescopes, it's just a mess, a bubbling, boiling, turbulent mess, and you can't even tell it has rings. So the magnification you use should simply be in keeping with the conditions. If you have very, very steady conditions, then you can boost up the image size. Otherwise, you'll just be boosting up the turbulence and won't be gaining anything by using higher power.
And of course, you can see some of its moons as well. I was looking up earlier, actually, that when Cassini-Huygens, when that launched in 1997, we only knew of 18 moons. But now there are 53 confirmed moons. And even if you don't have a telescope, at the moment, if you've got a half-decent pair of binoculars, as long as you hold them steady, you should be able to spot the largest moon, Titan, at the moment, which is just adds that extra little bit of flavor. It's going to be quite small, and it's got to be a good night. It's got to be good seeing, but you should be able to see Titan through a pair of binoculars. Bob,
Yeah,
who
at
was
time
it
it's almost
that?
always brighter than ninth magnitude, so it's even technically visible through binoculars. Not a difficult
Yeah,
object. The thing about Saturn, unlike Jupiter, Jupiter is only tilted 3 degrees from straight up and down, and so the rings, I'm sorry, the moons form a straight line because they circle
yeah,
the equator of Jupiter. But Saturn, with its almost 27-degree tilt, and the rings, by the way, circle the equator, and the moons circle the equator, which means, just look at it, it means that they can appear to the right or the left of Saturn, but they can also appear below it or above it. They will not be in a straight line. They will be an extension of that tilted ring plane. And so, unlike Jupiter, where it's easy to see what the moons are, there are those four in a straight line. One may be behind
mhm,
Jupiter at any given time. With Saturn, they're all over the place. They're surrounding
yeah.
Saturn. And as for identifying them with Jupiter, it's very easy. The brightest is always Ganymede. The fastest is always Io. You can always tell one from the other. The
Mhm,
dimmest is Europa. So you can just spot them without any chart.
yeah,
With Saturn, it's another story. When
yeah.
I was a kid, we only knew about nine, and then the 10th, Janus, was discovered. And I remember their order from Saturn. If you'll allow me to bore everybody with the mnemonic device that I remember
Oh,
from,
do.
from learning their distances after Janus, we used Met. I met Dr. Thip. So Met was Mimas, Enceladus, Tethys, Dione, Rhea, and then comes Thip, which is Titan, the great Titan, so much larger than any of the
Yeah.
others, over 3,000 miles wide. Hyperion, Iapetus, and finally Phoebe, which is the weird one because that goes around in the wrong direction, takes almost 2 years to circle Saturn. Obviously a captured moon. The others probably were there right from the get-go, right from the beginning with Saturn.
Yeah, and this is actually the position of them tonight, and it's one of the reasons why you can see Titan through binoculars, because when it is closer to the planetary disk, you just can't get that separation visually, especially in the glare. This is the wide field view. As I say, we turned up the exposure time on this specifically so that we could capture some of those moons, and there is Titan. It is that very bright spot to the right. In the clubhouse, if you're interested in looking at Saturn's moons and identifying them in your images, there's a whole page there that has this lovely little utility that you can use to identify them. And it also shows you, I did a composite image once of on this very telescope, showing how tiny Saturn is actually behind that huge burnt out ball. If you look at the size of that burnt out ball that we can see in the image, Saturn is actually only about a quarter of the width of that, hidden in all of that glare, which is why we can never see very well, those innermost moons, because to have an exposure long enough to see them, you burn out Saturn itself. So, Bob, do you ever get to see is it the Encke division, the very outermost, the very thin division?
No,
Can you
I
see
never
that
have.
visually?
And with all the years and with moments of very steady air, I have not. However, a friend of mine, a Hawaiian Japanese fellow who observed Saturn, did see the spokes radiating from Saturn outward
Wow.
before they were ever photographed. And as you know, they were thought to be impossible because how can you possibly have radial lines in a straight line
Yeah.
heading from Saturn lying on the surface of the
Mm.
rings? But observers in Hawaii on the slopes of Mauna Kea actually saw them
Had seen
and
them.
drew them and
Wow.
sketched them and submitted them before they were seen. So that would be, you'd have to list that as the most challenging feature of
Well,
Saturn.
that's going to be an interesting one to see whether or not we can ever actually bring that out. I think we're going to have to be quite clever on the exposure time, the settings of the video camera for that. But I haven't seen that in an amateur image
No,
before.
and
So
I
that
know I've never
just
seen them
remind viewers
photographed because
what. j-
I've never seen them photographed through an earthly telescope, so they're
yeah,
extremely challenging. We'll say that in maybe 40 years of being an observatory director, in addition to Slooh or beyond Slooh,
mm,
and I don't know, thousands of people certainly coming to our observatory to see it. We have a Takahashi refractor and a 12.5 inch research grade reflector. The
mm,
comments about Saturn are different from any other celestial object. I tell you, Paul, half the people who look at Saturn through the telescope say one of two things that I never hear about anything else. They say
mm.
either, oh my God, or that's not real, as
Yeah.
if we had a make believe slide posted on the far end of
On the end.
a hollow
Yeah.
telescope tube. That's not real, or oh my God. In other words,
Mm,
it hits people with a visceral impact that there are only a few celestial sights. I think you would agree that a total solar eclipse is one
yeah.
of them. Perhaps the moon and its wondrous craters, the first time you're seeing that through a telescope, that
Mm,
counts. But you could certainly count on the fingers of one hand the celestial objects that have that
yeah.
kind of a
You could.
visceral impact on
Yeah.
people, on everybody.
I've had exactly the same experience. The reaction to Saturn, seeing that through a telescope for the first time. I've heard the most extreme reactions there, and people almost do that kind of cartoon double look, because it is such an amazing sight. And I certainly remember the first time I looked. I was on my own in the garden with my brand new 10-inch telescope, and I had just commanded it with my voice. I said "Slew to Saturn," and I peered through the eyepiece, and it was remarkable. It was absolutely remarkable. And so often with telescopes, it's actually a disappointing view. Not so much with the planets, but certainly with deep sky objects. We never really get to see a decent, nebulae or galaxy through a telescope. Maybe globular clusters, they've got a bit of a wow factor. But other than that, I think you're right, Bob. It's Jupiter, it's Saturn, it's the moon. Um, but Saturn is always the biggest draw, and
Yeah,
certainly gets the
and then
biggest
and then
reaction.
there's the strangeness factor. Of course, Galileo first saw it in 1610. In all his drawings, he depicted the rings as kind of as if they were
Detached, weren't
handles
they?
on a teacup. And it took until Huygens and Cassini, now we're talking about half a century later, as telescopes
Mm,
got better and better and better and better, before anybody correctly ascertained their true nature. And I'm convinced the reason for that is that nowhere on Earth is there an example of a ball surrounded by unattached rings. So
yeah,
this was the first celestial object
yeah,
that looked truly unique and alien and had no earthly analog. A nebula looks a little like a cloud.
yeah.
A globular cluster looks a little like spilled sugar, let's say, on a piece of black velvet. There are analogies, but not for Saturn.
Yeah, and it's one of the places that I wish I could see from maybe one of its moons, or in a passing spaceship. How must we've seen even the Hubble, images of it. How What would it feel like to actually be close up to all of that? It would be so alien. It would be once again such an alien thing to our brains, that I think it would be quite. It would take your breath away. I think it would be very difficult to comprehend in that moment. Imagine just being on one of the moons, and I know a lot of the moons are tidally fixed, aren't they, to Saturn, but one of the moons that does actually rotate in comparison, to see Saturn maybe rise above the horizon. What a
That's right.
sight
And
that
to see
must
it
be.
showing phases, which you cannot see from Earth, to see a
Yes.
crescent Saturn, for example, and all the different
Yeah.
interplays of the rings casting its shadow on the ball of the planet.
Yeah. And there we see one of these. We need to wrap up soon, but we just saw there one of the little shepherding moons, just there, and we still don't fully understand, do we, the mechanics of Saturn's rings? But we got a far better understanding when we started seeing some of these Cassini-Huygens images, especially when we saw these little shepherd moons, maybe with two of them on either side of one of the thinner rings, just shepherding all of the particles. Amazing mechanics are going on up
It, wa-
there.
Do we have time for me to spend just a minute on the difference between our north facing view that we have right now and the south
You are
facing
among
view that we
friends,
get in
Bob.
15
We've
years?
got Slooh members here. We've got Astronomy Magazine readers here. No doubt, we know that you're a Slooh member favorite. We know that most people of Astronomy Magazine turn straight to your Strange Universe column. So take it away.
Well, thank you. Saturn is unique in that almost 30-year orbit around the sun. Of course, we take turns at 15-year intervals looking at the north side of the rings. That's what we're seeing now. And by the way, that's the one where the pole has that odd hexagon on it.
Yeah.
And then there's the south side of the rings that we saw 15 years ago, almost 15 years ago, 13 and a half years ago. And then we'll see in another 15 years or so. You'd think that they'd be symmetrical, that they'd be similar, that we'd say, who cares? But Saturn is unique in that one side really has many advantages to the other side. And I hate to say it because this is gorgeous, the north side, but this is the inferior side. And here's why.
Oh.
As Saturn goes around the sun, of course, it has its closest approach to the sun, apogee and perigee. It has an eccentricity of about 0.05. It's much more, 5 times more eccentric, I'm sorry, 2.5 times more eccentric than Earth's orbit. So it comes closer to the sun sometimes than others. Well, right now, it's on the far side of the sun. It's near its perihelion. But when we see the south side, it's near its aphelion. When we see the south side, it's near its perihelion. It's near the brightest side, the closest side. And so Saturn gets significantly brighter when we see that side. At the same time, that's the part of its orbit when it's riding high for people in the northern hemisphere. That's when it's passing through Taurus and Gemini and Cancer. Whereas now, when the rings are wide open, it just so happens that it always goes through Scorpius, Sagittarius, in other words, the lowest, most southerly points. It's lowest in our sky. We're looking at it through the maximum amount of air. In other words, we're struggling to get a really clear image. And so it almost like works through a set of gears, that everything either comes together for Saturn, closest approach to us, highest up in the sky for that southern side of the rings, and then everything goes south, everything goes sour for the northern side of the rings. And I don't want to put a bah humbug, terrible, cynical view, because this is gorgeous. I guess what I'm saying is to everybody, eat your health foods, work out at the gym, wait those 15 years, because the other side of the ring, if you like this, the other side of the rings is even better.
Okay, so 2032 or something like that, meet us back here. Now, actually, that description, Bob, I've never actually heard this before. And in the clubhouse, in the Slooh clubhouse where members kind of hang out and share images and things, Maynard has shared his Saturn images over the last decade, from 2003 when he first started, using Slooh's telescopes. It will be interesting, actually. I'm going to take another look at those, and I'd urge Slooh members to do the same thing. And here we go. There is the southern hemisphere. We'll take a look, Bob, and we'll review them with that in mind. So thank you for that.
Sure.
Now, just before we do
I should also add that it's not just closer to the sun, but Saturn also gets significantly closer to Earth for the southern view, and therefore it's larger and brighter. And our magnitude now is 0 on the nose, 0.0, but it actually gets to about -1. In other words, it gets almost 3 times brighter when we're seeing the south face than the north face. So the two are very asymmetrical when it comes to observing them.
Fabulous. Bob, thank you so much. We've run out of time tonight, but thank you very much for sharing your knowledge about this most beautiful of planets, isn't it?
Oh, my pleasure. Thanks. It's an honor to be here, Paul.
Thank you, Bob. That was Slooh astronomer and Astronomy Magazine columnist Bob Berman. Don't forget, Bob does 2 live shows for members each week on Tuesdays and Thursdays. They are always fascinating, educational, and great entertainment, and they're all illustrated by the live views from the telescope. You saw a glimpse of that actually earlier. The 17-inch telescope went on to its next mission that the members were controlling. It looked like maybe the Swan Nebula or something like that, maybe. So it looked pretty cool. Anyway, well, that just about winds up our coverage of Saturn at opposition tonight. We've had some terrific insights from Slooh astronomer Bob Berman. We've heard some of the myth and lore from our expert Trisha Ennis, and we've seen some fabulous live images, live image streams from Slooh's Canary Islands Observatory. But before we leave you, I want to remind you about some shows and events that we've got coming up here at Slooh. As I said earlier, you can catch Bob every Tuesday and Thursday for an hour each night, starting at 6 p.m. Eastern Time. Each week, he takes us on a tour of several objects that he's scheduled in the Slooh telescope. So that's always great fun. Also on Tuesday at 9 p.m. Eastern, Eric Edelman joins us for his weekly broadcast of Down to Earth, where he attempts to bring the fascinating stories and advances of space, you guessed it, kind of down to earth. Always entertaining. Loved Eric's piece that he did on aliens and alien worlds. He studied exoplanets when he was at college, I believe. And would you believe yoga enthusiasts are in for a treat later this month, as Slooh is going to be on site for the annual Wanderlust Yoga Festival in Vermont. I hope I said that right. Yeah, I'm a Brit, so excuse that. That's the 16th to the 19th. We're sponsoring a couple of sessions, and Bob Berman is going to be on hand to guide the attendees around the night sky objects from that location using one of our partner Celestron, one of their new telescopes, which is going to be quite cool for them to use that. Well, I hope you've enjoyed tonight's show. Please, Astronomy Magazine readers, if you haven't tried Slooh out, you should give it a go. It's a great place to be, a Slooh community. It doesn't matter what level you want to operate at. Come along and join us. It really is great fun. That is it for tonight. I'm Paul Cox, and this has been Slooh. We will see you again very soon.